Here, just quick helpful reminders about some review skills that we have, knowing that we're putting in a new application to some old skills. So in your assignment today, you're going to be operating with scientific notation. These are old skills that we know already, but just we have a new little context to them. Let's dive in and let's check it out. So the old skills that we do know already come from multiplying common bases with exponents. And when we look at these are problems that look something like this. M to the third times m to the fourth equals m to the seventh. We know that's true because that's 3 m's, m to the third, being multiplied by 4 m's, all being multiplied together, so multiplication signs in between all of those as well. One gigantic multiplication chain gives us those 7 m's, 2, 3, 4, 5, 6, and 7. We also know with some of our old skills that I can put in different coefficients in front of those. So if I go 4m to the third times, let's go 7m to the fourth, I still have m to the third times m to the fourth, so I'm still going to multiply those together, and my shortcut is to just simply add those exponents like I did up here. So that would give me an answer of m to the seventh, but I have to now deal with these two coefficients. Since I know the numbers and since they don't have exponents at all, they're just actual numbers, 4 times 7 is 28. I know I can just multiply those coefficients together and multiply those common bases. I would get 28m to the seventh. Big thing to remember, this is 4 times m to the third and 7 times m to the fourth. That's still one gigantic multiplication chain that I'm putting all together, so I can pick and choose and go out of order which of those numbers I need to multiply. That gets us to our new skill, multiplying scientific notation. When I'm multiplying scientific notation, we'll go scientific notation. I got to think about those exact same things. I might have a number, 3.17 times 10 to the fourth. So again, I have a multiplication chain, 3.17 times 10 to the fourth, two numbers being multiplied together. Then if I'm multiplying that by another scientific notation number, 4.73 times 10 to the seventh, again, I have another multiplication chain. And so now I just made one gigantic multiplication chain. Just like I did in the previous problems and then those previous skills that we know, I have common bases of 10. I can take those common bases, and since they have exponents, I can use my shortcut about adding those exponents together. So now I know I can have 10 to the 11th, because if we think about this, this is 4 10s being multiplied together, this is 7 10s being multiplied together. As a giant chain, that's 11 10s being multiplied. Now, what can I do with my other stuff? Well, it's just similar to what I did with my coefficients last time, is I can just take those and I can multiply those coefficients together. Because again, it's one gigantic multiplication chain. I can just kind of go and pluck things out of order. So I can take the first term times the third term, and since they're common, or not, they're not necessarily common bases, but they're actual numbers. There's no exponents to them, and it's a multiplication chain, so I can just multiply. 3.17, I'm just plugging into a calculator, times 4.73, gets me 14.9941 times 10 to the 11th. Now, that's not in scientific notation, so I just got to adjust something. If I was to take this and actually calculate this out, I would have to move my decimal point over 11 spaces to the right. If I think about that, and really what I need in order to write in scientific notation, I need to put my decimal not here, but actually here. So if I had 14.9941 times 10 to the 11th, the exact same number is 1.49941 times 10 to the 12th. Because if I think about what I'm really saying here in this top red number, the decimal point's moving 11 numbers to the right. And now when I shifted it back one, it's moving 12 to the right. And it's still going to be the exact same number because it's still moving the exact same final distance away from where it is currently. So now if I was writing this in scientific notation, I would just simply say 1.49941 times 10 to the 12th. In order for me to get there, I multiplied my two exponents on my 10s together by doing my shortcut of adding them. And then I multiplied my two coefficients together. Then I took a look and I looked at this final box and I said, is this in scientific notation? No, it's not. So I just simply adjusted it by sliding my decimal one over and then adjusting my exponent up to the top to reflect the exact same number. Other operations you're going to go through are division with scientific notation, Before we see an example of that, let's remind ourselves of some skills. If I do m to the fifth divided by m to the third, I'm going to get m to the second. Our shortcut, we said, was this: when I have common bases and exponents, to subtract those exponents. We said that was the same as having 5 m's on the numerator, 3 m's on the denominator, pairing those m's together and seeing that I have 2 m's left over in the numerator to give me that answer. We take that one step further with other skills that we know, and we add some coefficients. 12m to the fifth being divided by, actually let's switch up colors here, 12m to the fifth being divided by 3m to the third. I just pulled the exact same problem from before, so I know that based on my subtraction, I should say my same exponents from before, based on my subtraction idea of common base exponents, I know I'm going to end with m to the second again. M to the second. So what I know now is that I can take a look at my two coefficients, 12 being divided by 3. Because remember, this numerator is a multiplication problem. 12 times m to the fifth, 3 times m to the third for my denominator. That means I can split these off into two essentially separate fractions. And like I did here, I have m to the second as a result of this black box. As a result of the red box, I can just do 12 divided by 3 and get 4. So now my final answer is 4 times m to the second, or just 4m to the second once I mash them together. I look to see now how I can connect those things to scientific notation. And in scientific notation, I would have something like 4.7 times 10 to the third being divided by, let's go 1.92 times 10 to the second. So if I look at these things, and again, I have a multiplication chain at the top in my numerator, I have a multiplication chain in my denominator, and so if I'm looking at those, I can treat them like two separate fractions. And now let's change up those colors a little bit, so now I can talk about the blue box. In the blue box, I have common bases with exponents, meaning I can just subtract my exponents. I'm left with 10 to the first. Then in my black box, I don't have exponents, I have actual numbers, so really I just have a division problem. 4.7 divided by 1.92. Plug that into a calculator, 4.7 divided by 1.92, and I get 2.44. I'm going to round up to 8. There's a lot of decimals after that. I'm just going to do some rounding to the thousandths place. And so now I'm just going to multiply those together again with my 10 to the first, just because that's how we bridged those two fractions together. And so I'm going to end up with 2.448 times 10 to the first. And there's my final answer. It's in scientific notation. My decimal's in the right spot. I got myself and I just divided my two separate parts, my exponents with 10 as the base, and my coefficients, which were the actual numbers. So operating with scientific notation, totally based in review skills that we have, might just need some tweaking to rewrite your answer in scientific notation. Here, we didn't need to. Back in the multiplication problem, we did.